In this video, I want to talk about R matrices and arrays. Let me start by briefly talking about what is a matrix, the concept of a matrix. First, just reminding you what a matrix is from the mathematical point of view, and then the implementation of this type of object in R. From the mathematics point of view, here's the entry in Wikipedia about a matrix. And if you read the first paragraph, as you can tell, a matrix, plural matrices, is just a rectangular array or a table typically consisting of numbers. You could also have symbols or more generally expressions that the way they are arranged in this type of object is in rows and columns, giving you a grid-like structure, a tabular structure, which we use to handle this type of mathematical objects. So the concept of a matrix, we have the matrix as in math, and then the concept of matrix as an R data object. So let's focus about what a matrix is in terms of R. R matrices are very similar to math matrices, mathematical matrices. And I have to say that to a large extent, an R matrix is actually intended to work or to function as its mathematical version. There are certain things that an R matrix has that they don't really exist in the mathematical version of this type of objects. For instance, R matrices, they can have row names. They can also have column names. And of course, because we're going to be handling data in general, and from the statistical perspective, you could also have missing values as part of the entries in an R matrix. So these concepts are not typically found in matrix algebra, but in the branch of math that has to do with mathematical matrices. So let's start by just describing how we can go from vectors, R vectors, to R matrices. So what I'm going to explain here is just what R is supposed to do behind the scenes, so that first you understand the concept for how R works internally, and then we're going to review a bunch of functions for how to do this with code. Say you have some vector containing 4 elements, 2, 4, 6, 8. Again, this is in pictures, and this is supposed to be an R vector. And imagine that what we want to do is to rearrange these numbers into a 2x2 matrix or rectangular grid. So let's say we want to rearrange things like this in a table, a small rectangular array with 2, 4 in the first column, 6, 8 in the second column. What I'm writing here between parentheses, this 2x2 corresponds to 2 rows and 2 columns. In R, we call these the dimensions of the matrix. Again, I'm going to show you something just for illustration purposes. We are not supposed to create matrices like this. This is just an explanation of how R works internally. So let's start by defining our X vector. And let me use the combine function. Of course, there are other ways in which you can start defining X. And what R will do is going to take an input vector such as X, and it's going to give dimensions to this vector. So we could actually use the dim function, the dim function. What we need to provide is a vector with 2 or more elements. So let me provide dimensions 2, 2 to indicate that we want to rearrange the values in X, first using the first index in the combined vector that corresponds to the number of rows. The second index corresponds to the number of columns. And here I'm using actually the abbreviations in R, n row for number of rows, and call for number of columns. Again, this is terminology, and it has to do with this idea of dimensions that we previously mentioned. So what R will do is it's going to take the input vector. Here again, it is in picture 2, 4, 6, 8, and it will take the first two elements. Those are going to be considered to be mapped or correspond to the first column. And then the second element, 6 and 8, these are going to be mapped or rearranged as the elements of the second column. So again, R internally will organize the elements like this: 2, 4 in the first column, 6, 8 in the second column. And this is why we say that R internally stores values, stores matrices in what it's called column major way or column major mode. Now, important, we don't really create matrices like this in R. What I mean by that is we don't really use the dimension function and pass it a vector and then specify what are the numbers of rows and columns in which we want to rearrange things. What we actually use in R is the matrix function, and then there is a couple of other sibling functions that we could use to build matrices. So let me give you an example of how we actually create matrices in R. So I can create an object, let me call it mat for matrix, and then we use the matrix function. The main input is a vector. Let's assume that you have a vector x, like the one previously defined. And then we define with the n row argument the number of rows in which we want to organize things. Again, assuming that x is 2, 4, 6, 8, it has 4 elements, I could rearrange them in a 2 by 2 matrix. So explicitly specifying 2 rows and 2 columns with n row and n col. Now, ideally, the product of the dimensions, in other words, the product of whatever value you specify in n row times whatever value you specify in n col, this ideally should be equal to the length of the input vector x. Notice that I say ideally with a little star here. That's not really a rule, but it's highly recommended. If you pass a vector with a different length that doesn't match the product of n row times n col, what R will apply is the recycling rules. So let's see a couple of more examples. Say we have, or I would like to obtain a matrix A with 2 rows and 3 columns. So let's first write something in a more algebraic sense, in a more linear algebra way. And here's the matrix that I would like to obtain: 2 by 3, what elements in the first column? 1, 4, 2, 5 in the second column, 3, 6 in the third column. So let me show you two options, two ways in which you can define a matrix like this. One is, again, calling the matrix function. I could specify an input vector, and here I'm going to use a generic numeric sequence from 1 to 6. And then again, I'm going to specify number of rows 2, number of columns 3. And super important, I told you that our matrices by default are defined column major. So let me write these yellow arrows just to indicate that idea that, again, this is R. It will organize elements by columns. So if I pass an input vector 1 to 6, n row 2, n col 3, just like this. So let me just consider these 3 arguments. What R will do is organize things 1, 2, that's going to be the first column, 3, 4, that's going to be the second column, and then 5, 6, that's going to be the third column. Now, I don't really want this. What I would like to get is what I have here in the upper part. So we can use the by row argument. Here I'm just going to write the same command. 1 to 6, number of rows 2, number of columns 3, and then specify the by row command, turn it on equals true. And here, by doing this, R will effectively organize things in this way. So R will create a first column 1, 4. The second column will be 2, 5. And then finally, the third column will be 3, 6. So this is what R will create with this command. Okay, so that's one possibility. Let me show you another possibility. Again, here's the matrix that I want to create. So let's see how to do that. I could, for example, I could also write, again, same idea, with invoking the matrix function. I could pass an input vector with elements already organized by column major, so to speak. So this guy 1, 4, 2, 5, 3, 6. And then just to specify that I want 2 rows and 3 columns. Depending on what is the input vector, right? So in this case, this input vector has a length of 6, so there are 6 elements. You don't actually need to explicitly give the dimensions in row and col simultaneously. You could actually give one of them in row 2. So compact way, an alternative way to write the same command, it's something like this. So I would just need to specify n row equals 2, close parentheses, and that's it. So this command will allow me to do the same thing as the above command. Or alternatively, I could specify an input vector, same input vector, with, instead of specifying n row, I could specify the number of columns and col equals 3. And R will also fill in the blank. So it's gonna fill the missing argument with a value such that the product of n row and n col matches the length of the input vector. I want to mention that matrices are also atomic structure, atomic objects. And if you remember the concept, the idea of atomic, it simply means that all the values, all the elements in an object have to be of the same type. So they all have to be homogeneous values, either all logical values, I'm just going to abbreviate it, or all integer values, or all double values, or all character values. Again, these are the 4 most common data types. Of course, you also have raw and complex, but I just want to focus on the 4 most common values. Now, the reason why matrices are also atomic, if you remember what I said, using the matrix function to create a matrix, typically you're going to need to provide an input vector. And because input vectors are already atomic, this is the reason why rearranging things in a rectangular array with a matrix will also return an atomic object. So this is one reason why matrices are atomic.